So this is a quick introductory lecture on introducing the concept of loops. So I'm going to talk about loops. Hopefully by the end of the series of lessons on loops, you will be able to list through files and use commands to manipulate those files. There are a variety of different types of loops. The main type of loop that I'm going to talk about today are for loops. What are loops? First, loops are a powerful programming tool that enables you to execute a series of commands repeatedly. They are one of the most useful tools out there. We can use them to leverage the power of a computer to do tasks that are repetitive that would otherwise take us an enormous amount of time. Again, there are different types of loops. There's the for loop, the while loop, the until loop, a select loop. We are going to focus on the for loop in this class. And the for loop operates by working on a list of items. And what it does is it repeats a set of commands for every item in that list. So you always have to give a for loop a list. And then what it will do with that list is it will iterate through that list. In other words, it will perform a set of actions for every item in that list. So it's going to go through that list one by one and perform that set of commands. And when you do that, you're looping through the list. Another key component to a for loop is a variable or a looping variable. And this looping variable is a symbolic name or a variable that references a certain amount of information. And what happens in a loop is that every time through the loop, that variable's name is going to change. And so you could think of X and Y and Z in mathematics as being variables, and how when we often solve them, when we solve for X, the number may not, or the solution may not always be the same. But X is still X in an equation. And in this way, variables still function the same way in computer language. The syntax for a loop is pretty straightforward. You type the word for, you create a variable. In this case, I'm just going to call it var. You say in, use the word in, and then you identify a list of items that the loop will iterate through. And the loop will continue to iterate through this list of items until it hits the last item in the list. So the number of times that a for loop iterates will depend on the number of items in the list. We then use a do in Unix, whatever series of statements we want to be executed on that word, and then a done at the end. And remember that as we go through this var, the value of it will change. So the first time through the loop, it's going to be equal to word 1. The second time, it's going to be word 2. The third time, it's going to be word 3, etc., until it gets all the way to the last word in the list. One of the ways to understand how loops work is to visualize them and to have an understanding of how the flow of information works and goes through a program. And so in computer speak, we might call that either flow control or control flow. But basically, it's just the order of operations. It's the logic of the program. And when we write our code, we create this logic. And these become the rules or the axioms of the program. And the computer will not violate those as long as it's written there. And what it does in the process is it creates sort of a computational logic, which has its origins in mathematics. And so a lot of the notation we use is actually very similar to mathematics, some of the vocabulary too. But one of the big differences is that instead of writing equations, we're going to be writing logical programming. And these are basically sets of sentences that express facts and rules. And a key component of flow control or control flow is that it's often driven by these Boolean logic circuits or switches. So we have different outcomes that could happen. We could if something is true, then we could have one series of outcomes. If something else is true, then we would go down a different pathway of possible outcomes. And we can even nest other if statements within those existing if statements. We refer to these kinds of switches as conditionals because they depend on the state of a variable. And usually these are treated as sort of true-false evaluations. There are shortcuts for us in how we might think about conveying or discussing code. And there are sort of two ways that I want to talk about. One is to create something called pseudocode. And this is an informal description of how a program or algorithm works. And then the other way is to generate some sort of flowchart. Now, why would we do this? Well, sometimes we want to find a way when we're actually building algorithm or building a set of operations to solve a problem. We don't actually want to write all the code because lots of things could go wrong in that process. We just are trying to visualize or understand how we think our program needs to progress in order to solve the problem we wanted to solve. What set of operations can we identify, right? And this is actually a very important part that is often, I think, not fully appreciated, especially by first-time programmers. But the better you can be at writing pseudocode, at designing flowcharts, the much easier your coding will be, ultimately. So in this world, there are sort of different symbols that represent different outcomes. So the arrow is like what's to do next. The rectangle is for statements and actions. The diamond's for decision-making statements. The parallelogram is for input-output. And the oval is for start and end. So if we were to diagram a loop, it would look something like this. We'd have a start of the for loop. We'd have some input information. Then we'd have our list of items that we're going to iterate through. We have our looping variable here. And every time through the loop, right, we're going to take this looping variable. We're going to evaluate some statement. Maybe we'll output some information. We're going to come back, and then we're going to go on to the next variable, right? And then we'll do the same circle, on to the next variable, same circle, on to the next variable, right? Same next circle. And then right before we get to this last one, that would help us identify that that is actually the end of the loop. That is my quick introduction to loops. Please watch the other video that will have a more detailed description of and presentation of actual Unis code.